Hello and welcome. In this video, I will show you step by step how to create a Flappy Bird game in Unity. Don't forget to subscribe for more tutorial videos like this. Also, I will share the necessary sprites as a downloadable file in the video description. Enjoy watching. We start by selecting the 2D mobile template from Unity Hub to create our project. This template is optimized for mobile development and provides a great starting point for our Flappy Bird style game. And now, we have a clean and fresh Unity scene in front of us. Now, let's create the necessary folders and organize our project. We'll set up folders for sprites, scripts, and other assets to keep everything structured and easy to manage. Import our sprites into the project and start turning them into game-ready assets. We'll set their positions, adjust their settings, and make sure they look and function correctly in our scene. This is where our game starts to take shape. Using the slice method, we define multiple sprites from a single image. This allows us to split a sprite sheet into individual elements, making it easier to use them in our game. We need to adjust our scene for a proper mobile resolution. To do this, we'll set the game view to match common phone screen sizes, ensuring our game looks and plays correctly on different devices. I dragged the background from the project panel into the scene. Next, we need to adjust the camera size to match the background proportions. This ensures that the background fits perfectly within the game view, creating a seamless visual experience. Make sure that our scene is properly aligned and everything is positioned correctly. This is how our background looks in the game scene. However, you may have noticed that it appears a bit blurry. To fix this, we need to remove the filter applied to the background. As you can see, it looks much better now. The background is sharper and clearer. Now, to work more efficiently, let's update the names of the objects in our scene. Renaming them properly will help us stay organized. Let's add a wing flapping animation to our bird. First, we create a new folder named Animations to keep things organized. Next, we select our bird and click on Create Animation to start making our animation. We take 3 different sprite images of our bird and copy them into the animation panel. These sprites represent different stages of the wing flapping motion. By arranging them in sequence and adjusting the timing, we create a smooth and natural-looking flapping animation. This will make our bird feel more lively and dynamic in the game. As you can see, it turned out really well. We need to set the bird's layer to 1 so that it doesn't get hidden behind the background. This step is important to ensure that our character remains visible and properly layered in the scene. Let's place the ground object in our Flappy Bird scene. This will act as the surface that the bird interacts with, completing the game environment. Change the draw mode from simple to tiled. This will allow the ground texture to repeat seamlessly, ensuring that it covers the entire width of the scene without stretching or distortion. Let's add a rigid body 2D component to our bird to enable physics interactions. Fine-tune the physics settings, set collision detection to continuous to ensure precise collision handling, especially at continuous. Also, change sleeping mode to never so that the rigid body stays active and responsive at all times. Add a collider to our bird to handle collisions. You can use a circle collider 2D or capsule collider 2D to fit the shape of the bird properly. Adjust the size and position to ensure accurate collision detection without unnecessary overlaps. Don't forget to add a box collider 2D to the platform in our scene. This will ensure that the bird can properly collide with the ground instead of falling through. Let's run our game and test it. Everything is perfect. For jumping, we will implement the bird's jumping behavior in our code and applies an upward force to the rigid body 2D component of the bird. First, we create a jump force variable as a float to define how strong the bird's jump will be. Then we declare a rigid body 2D component and assign it in the start method using getComponentRigidBody2D. In the update method, we check if the left mouse button or screen tap is pressed. If it is, we apply an upward force to the bird using add force to simulate the flap. This will allow the bird to jump and stay in the air. This basic script will make our bird jump. Now let's run the game and test if everything works properly. Click to see if the bird flaps its wings and moves upwards as expected. As you can see, our bird is jumping perfectly. You can adjust the jump strength from the inspector by tweaking the jump force value. Play around with it to find the best balance for smooth gameplay. From the project panel, we drag our obstacle pipes into the scene. We will position them properly to create a challenging path for our bird to navigate through. To keep things organized, I name the pipes as top pipe and bottom pipe. Then, I group them under a single parent object. This will make it easier to manage and move them as a unit in our game. As you can see, the basic design of our game is almost complete. Now, we can focus on adding more features, polishing the gameplay, and making everything look even better. Let's write the movement script for our pipes. We'll make them move from right to left, just like in the original Flappy Bird game. This will create the challenge of dodging obstacles. Let's test it and see if our pipes move correctly. Don't forget to attach the script to the pipes, otherwise, they won't move. If you want, you can also the speed of the pipes to your liking. Just tweak the move speed value in the inspector to make the game easier or more challenging. Before moving on to the pipe spawner, let's modify our bird script. I'll create a Boolean variable called instead. If our bird is still alive, it will be able to jump. But once it dies, the pipe spawner will stop generating new pipes. Let's write the pipe spawner script. This script will automatically spawn pipes at set intervals, making the game more challenging over time. We define a GameObject pipeRefab variable. This will store the prefab of the pipes we will spawn in the scene. Then we create a float spawn rate variable to determine how often the pipes will appear. Additionally, we add min height and max height variables to ensure that the pipes spawn at different heights. We need to check whether our bird is alive or not before spawning pipes. To do this, we access our bird script from within the pipe spawner script. Let's create a spawn pipe function that will handle the instantiation of our pipes. We will use an if statement to check whether our bird is still alive. If the bird is alive, the pipes will continue spawning at regular intervals, keeping the game dynamic. However, if the bird dies, the spawning process will stop. This logic ensures that the game only progresses while the player is actively playing. We will use the random range function to assign a random height to the pipes. This will make the game more dynamic by ensuring that the pipes appear at different heights each time they spawn, adding variety and challenge for the player. Vector 3 to set the position of the object that will be spawned. After determining the correct spawn position, we use the instantiate method to create the pipe at that location. When spawning the objects, we set their rotation to QUATERNION.identity to keep them in their default orientation. The invoke repeating function allows us to call our function at specific intervals in a loop. By using this method, our pipes will spawn continuously at set time intervals, creating the endless obstacle course for our Flappy Bird game. We need to turn our pipes into prefabs. To keep things organized, I created a new folder in the project window and named it Prefabs. This will help us manage our game objects more efficiently. Let's proceed. Let's assign our script to the spawner object and enter the necessary values. Make sure to set the required parameters correctly so that our pipes spawn at the right intervals and positions. Alright, let's run a quick test. We'll check if our pipes are spawning correctly and moving as expected. If everything is working fine, we can move on to the next step. Yes, our pipes are spawning nicely, however, they appear a bit late after the game starts and they move a little too slowly. Let's fix these issues to ensure smoother gameplay. As you can see, the pipes now start spawning at the x-axis position of 1, ensuring they appear on time and flow smoothly into the scene. Our bird has started flipping, which is an unintended bug. Let's fix this by restricting its rotation on the z-axis using the collider settings. That's it, it's that easy. As you may have noticed, after spawning, our pipes move off the screen but still remain in the scene. We need to destroy them, otherwise our game will start lagging after a while. The easiest way to solve this problem is to make the pipes destroy themselves automatically after a certain period of time. This way, our game will run more optimally. After 3 seconds, the pipes will automatically destroy themselves. Let's test it now and see with our own eyes if the pipes disappear automatically after 3 seconds. Awesome, so far everything is going great. Now, let's integrate the UI system into our game to display the score. For this, right-click in the hierarchy, go to the UI section and select Text Mesh Pro. If it's not imported yet, the project will prompt you to import it. This process takes about 15 to 20 seconds, so don't worry. Alright, now we can continue. Before adding the text, we first need to properly configure the canvas. This is a crucial step in game development because an incorrectly set up canvas can lead to display issues, misalignment, and an overall poor user experience. If not adjusted correctly, UI elements might appear too large, too small, or even completely misplaced on different screen sizes. Now, we adjust the size and position of our text to ensure it appears properly on the screen. We want our score text to be centered at the top of the screen, so we align it to the upper middle part of the canvas. To achieve this, we modify the anchor presets, setting it to top and making sure the text remains properly scaled across different screen sizes. We are previewing the text in the simulator, and everything looks perfectly aligned. There are no misplacements or distortions, ensuring that the UI remains stable across different resolutions. We will learn how to integrate the Flappy Bird font that I found online into our game. Custom fonts help enhance the visual appeal and match the game's theme perfectly. Let's go step by step to ensure a smooth integration. For this, we need to go to the Font Asset Creator in the Windows panel and convert our font. This step is essential to ensure that our custom font is properly recognized and rendered in unit. Click on the Text Mesh Pro text object, drag the custom font we created into the font slot, and let's see the result. You can also adjust the font size from the font size option. Feel free to change it according to your preference. You can also customize the color, thickness, and horizontal alignment to match your desired style. Now, to accurately detect when our bird successfully passes through the pipes and award points accordingly, we need to create a new invisible object position exactly between the pipes. This object will act as a trigger zone, meaning when our bird enters this area, we will recognize it as a successful pass. To do this, we will make the object fully transparent, assign it a specific tag such as scorizoni, and enable the isTrigger option in its collider settings. This way, when the bird moves through it, the score will increase by 1. Ensuring this setup is done correctly is crucial for the game's scoring system to function properly. We create a new script called gamedev, which will be responsible for handling our game's scoring system. This script will manage the player's score, update the UI whenever points are earned, and ensure that everything functions smoothly. By keeping the scoring logic separate in the gamedev, we make our code more organized and easier to manage in the future. We define an integer variable called score to keep track of the player's points. Then we update the Text Mesh Pro UI element to display the current score on the screen. Every time the player successfully passes through an obstacle, the score will increase, and the UI will be updated accordingly. We create the onTriggerInter function inside our gamedev script. When the bird passes through the scoring zone, this function will be triggered, and we will call the addScore function to increase the score. And we call this update function inside the onTriggerInter event. We have set up our systems so that if our bird passes through an object tag as pointeria, the score will increase accordingly. This ensures that every successful pass between the pipes is rewarded. We then drag and drop our gamedev script onto the gamedev object in our scene. After that, we assign the necessary references in the inspector. And after that, don't forget to assign the pointeria tag to our object. This step is crucial to ensure that the scoring system works correctly. Our system is working great, but we noticed a small issue. As you can see, the score should be displayed as 0 on the screen right from the start of the game. Let's fix this now. In the start function, we set score equals 0, and then we update the text UI accordingly. This ensures the score starts from 0 when the game begins. Let's test it now and see if our score starts from 0 as expected. Great, we now have a fully playable Flappy Bird game. Congratulations! We are going to implement the collision system for our game. To do this, we need to assign the obstacle tag to both the pipes and the ground obstacle. This will allow us to detect when the bird collides with them and trigger the game over sequence. Our bird will collide with these obstacles, instantly ending the game. To detect this, we will use the onCollisionEnterToD function. This will allow us to check if the bird has hit an obstacle and trigger the game over process. We will set our isTed boolean variable to true here, which will stop spawning new pipes. At the same time, we will pause the game to ensure everything stops when the bird collides with an obstacle. Let's test it now. If we hit an obstacle, the game should stop immediately. Everything is working perfectly. You're getting really close to finishing our game. Now it's time to implement the death screen panel. This panel will appear when the player loses, giving them visual feedback that the game is over. Additionally, we will add a restart button, allowing the player to quickly start a new game with a single tap. We start by creating our button, but instead of keeping the default text, we delete it to make room for a custom design. Next, we replace the button's default appearance with a new sprite, making it visually fit our game's theme. Now, let's write the code that will reload our scene when the game ends. This will allow the player to restart the game seamlessly after losing. Of course, to make the button clickable, we need to set it active when the game ends. We'll use the setActive function to make the death screen panel visible at the right moment, ensuring the player knows the game is over and can restart it with a simple tap. Before testing, we need to link our script to the button. We'll assign the function that reloads the scene to the button's onClick event so that when we press it, the game restarts smoothly. Let's test it now and see if our death screen appears correctly when the game ends. The scene has reloaded, but we need to reset the game speed to 1 to ensure everything runs normally again. Let's fix it now. Awesome, we now have a fully functional Flappy Bird game. You have complete freedom to customize your scene and make it as visually appealing as you want. Try experimenting with different backgrounds, adding animations, or even tweaking the colors to give your game a unique look. For now, I'll be adding a few simple images to demonstrate how you can enhance the visual experience. Now it's time to add some sound effects to make our game more engaging and immersive. We'll be adding sounds for jumping, scoring, and when the player hits an obstacle. These small details will enhance the overall gameplay experience and make the game feel more polished. I have created a script called Sound Manager, where we'll manage all our sound effects. This script will handle playing sounds for jumping, scoring, and collisions, ensuring that our game feels more dynamic and responsive. I will create the audio source components, one for continuously playing the background music and the other for handling sound effects like jumping, scoring, and collisions. This will help keep the game audio organized and smooth. 3 sound effects will be enough for now. 3 sound effects will be enough for now: jump, score, and collision. We'll add these to our Sound Manager script and trigger them at the right moments in the game. In order to ensure our background music continues playing across different scenes, we use .destroying load on our Sound Manager object. This prevents the audio source from being destroyed when the scene reloads. Additionally, we implement a singleton pattern by creating a static instance variable, which ensures that only one instance of the Sound Manager exists at any given time. To avoid no-referencing XD errors, we check if an instance already exists before creating a new one. If an instance is found, we destroy the duplicate to maintain consistency in our sound system. For playing sound effects dynamically, we create a function that takes a string parameter representing the name of the sound effect. Inside this function, we use a switch case statement to compare the given string with predefined sound effect names. If a match is found, the corresponding sound effect is played using the secondary audio source, which is dedicated to sound effects, while the primary audio source continuously plays background music. We will access the Sound Manager script from the relevant parts of our game and call the appropriate sound effects. For example, when the bird jumps, scores a point, or hits an obstacle, we will trigger the corresponding sound effect. To do this, we first get a reference to our Sound Manager instance and call the function responsible for playing sounds. Our code is now complete. Now, let's move on to finalizing the scene adjustments and ensuring that all sound components are correctly integrated. We need to make sure that our background music is playing seamlessly from the start of the game and looping continuously without any interruptions. To achieve this, we should check the audio source settings and enable the loop option. Additionally, balancing the audio levels is crucial for creating a smooth and enjoyable gaming experience. The background music should not overpower the sound effects, and the volume should be set in a way that enhances gameplay rather than distracting the player. Alright, let's test our game now and see how everything comes together. We'll check if all mechanics are working smoothly, including... That's awesome! I'm glad to hear the game is looking great. If you followed along so far, thanks for sticking with it. Now, let's move on to building the APK. Prepare for the app build. First, go to Player Settings. Enter your product name, your game's name, version the current version number, and company name your developer name or company. Next, since the game is in portrait mode, under Resolution and Presentation, set the default orientation to portrait. This ensures the game always runs in portrait mode. You can also customize the color of the Unity logo that appears when the game starts. In the player settings, under Splash Image, you can change the Unity logo and set the background color to match your game's theme, making the initial loading screen feel more cohesive with your design. You can add an image for the icon that will be displayed for the game application. Great! The image you placed here will appear as the app icon on your phone once the game is installed. Once you've selected the build folder for your project, simply click on Build to start the process. Don't forget to switch the platform to Android. That's the golden rule. Now that our app is ready, we'll test it using BlueStacks. Alternatively, you can test it on your Android phone, and it should work just fine. If you enjoyed this tutorial and want to see more, don't forget to like it. Thank you for watching.